Okay, so let's take a look at some more percentages. So there's going to be a bunch of different ways to do these. I'm going to be starting on the question on the left, and all the questions on the right I'm just going to be bringing in slowly. So just this highlighted one, what is 8 out of 20 as a percentage? So I'm going to start with a nice formula. Is over of equals percentage over 100. So really using the equals over formula that we learned in chapter 2, using equivalent fractions, where something is over what it's out of is equal to the percentage over 100. So it says, what is 8? So 8 goes in the is spot. Out of 20 is equal to a percentage over 100. So I'm going to put it over 100, and then I'm going to figure out what that percentage is. So in order to get from 20 to 100, we simply times by 5. And if I do that to the bottom, I must do that to the top. 80 times 5 is 40. Therefore, my answer is 40%. Again, as you can see in the notes, there's tons of different ways of doing this. For example, I could use my calculator, and 8 divided by 20 is equal to 0.4. And then through our theory from the last section in 4.1, we could convert that decimal into a percentage. Okay, the next one here. Find 15% of 200. So again, I'm going to start off with over equals over, and it says find 15. So that's on the top right, that's the percentage from the formula above in the square, put it over 100. Now of 200, where does that go? Does it go on the top or the bottom? Well, is goes on the top, of goes on the bottom. Of 200, we are going to put on the bottom. Now, how do I get from 100 to 200? Well, I times 2, and I'm going in the same direction, so I times 2, and then I will get 15 times 2 is 30. Circle my answer. Now you could write out some English sentence that 30 is 15% of 200. And a great way to check our answer is we're going to do a division on our calculator. 30 divided by 200. 30 divided by 200 is equal to 0.15. And from 4.1, we know that 0.15, if I move the decimal 2 times to the right or multiply by 100, we get the 15% that we were talking about, so we know it's correct. Okay, this next one here, increase 200 by 15%. So, a little bit new, increase 200 by 15%. Excuse me? I have missed a question accidentally from the notes, so pardon me. We are just going to go back a second, and that will be our next question. So 25 is 20% of what? So over equals over 20%, following the formula, goes on the top or right. 100 goes on the bottom. Now 25 is, well, that goes on the top. And then we're wondering what's on the bottom. I'm going to call it X. So how do we get from, for example, 20 to 25? Well, I'm going to do that on the calculator. So off to the right, 25 over 20. 25 divided by 20 is equal to 1.25. So we know we're a factor of 1.25. Now, if I want to go from 20 to 25, I'm going to say times 1.25. And then I can go in the same direction and times 1.25. And 100, I do off my work off to the right. 100 times 1.25 equals 125. So we know that x equals 125. Now, I could check my answer like I did above, which I'm going to. So if I got x, I'm going to put that back into the left-hand side, which means that's 25 over 125. And if we do that, 25 divided by 125, we get 0.2, which from the last chapter, if we remember, we can times by 100 to get the decimal. So if I times that by 100 or move the decimal 2 places to the right, we get 20%. And we know that was the given information, so we know that we are correct. So these are going to be the 3 basic forms. They give you the is or the of or the percentage, and you have to find the thing that we're missing. So they're going to give you 2 parts of those 3, and we'll find the missing one. So this is the most basic way to do it. With algebra, we didn't actually ever have to use our calculator. Every single step we could have done with long division. And now we're going to take a look at some much more difficult questions using the same theory and some little bit of additional theory. For example, you might learn from your teacher or someone that you can do some quick method on the calculator, and that's great, and feel free to use it. But I want to try and teach to algebra. Again, I'm just using the calculator to make it a little bit quicker, so I don't have to show all the long division steps. Okay, so the next one, we are going to increase a number by 15%. So we're going to increase 200 by 15%. So there's a bunch of different ways to do this. So let's start off on the first one. Well, I could start exactly like we did above and do is over of equals percentage over 100. So increase a number by 15%. Increase 200 by 15%. Over equals over 15%. 100 goes on the bottom based on our formula. Is over of equals percentage over 100. Now, increase 200 by 15%. So I need to find 15% of 200. Now, to get from 100 to 200, we times by 2, and to get from 15, we times by 2, and we get 30. So we know that 30 is 15% of 200. Now, we can just simply take the 200 and add 30 to get 230. That's one way. Let's figure it out in a better way. So, I can just take a number and times it by the decimal, which is 15%. So, go back to the last section and learn why 15% is 0.15. And we get 200 times 0.15. Either do log multiplication. I'm just using a calculator for simplicity. But we get 30. Now, we're going to take 200. We're going to add the 30 to it, just like we did above. 200 plus 30 is equal to 230. The same answer. Now, there must be a better way. So we can do is over of and then add it. We can use multiply by the decimal to get it. Or, if you think about it, if you want to increase a number by 15%, for example, well, let's say I start off with this calculator. What percentage of this calculator do I have? 100%. If I increase it by 15%, I'm going to have 115%. Now, What's 115% as a decimal? Well, I'm just going to simply divide it by 100 or move the decimal back twice, which is equal to 1.15. Now, this is called the multiplier. It's always going to be 1 plus or minus the interest rate or the rate as a decimal. So 1.15 is the multiplier. Now, instead of doing all this math above, couldn't I just take the given information 200, and if I want to increase it by 15%, I'm going to make it 115% of what it used to be. So I can just simply multiply by 1.15. And 200 times 1.15 is 230. The same answer that we continue to get. Multiply by the percentage that you want to be. Multiply by the percentage you want to be. Obviously, the decimal, we don't actually multiply by percentages. So, now, what if I use that same theory to decrease a number by 15%? Well, if I start off with 100% of my calculator and I decrease the size of it by 15%, what percentage am I going to have? Well, off to the right, I'm going to do 1 minus the decimal, 0.15, and I get 0.85. So I'm simply just going to times 200 by 0.85. And on the calculator, 200 times 0.85 is equal to 170. Or I could have done the same thing as above and found 15% of 200, which we know was 30, and then simply did 200 minus 30. And obviously the same answer as we did above. In the last two cases, we just simply multiply by the percentage I want to be. If I want to find 15% of a number, times by 0.15. If I want to find 50% of a number, times by 0.5. If I want to find 80% of a number, times by 0.8. If I want to find 120% of a number, times by 1.2. If I want to increase a number by 20%, times by 1.2. If I want to decrease a number by 20%, times by 0.8. Multiply by the percentage you want to be. Okay, a couple more examples. So, find the percent change increase from 10 to 12. So, let's write the formula for percent change. Percent change, as you can see in the notes, is equal to final minus initial over initial. And this formula for percent change can be used all over the place. Either way, percent change I'm going to show as percent triangle. Triangle means change or delta. Percent change, substituting into the formula, the final 12 minus 10 over 10. From 10 to 12. 12 is the final, 10 is the initial. And 12 minus 10 is 2 over 10. On your calculator or any of the methods that we did before, equals 0.2, which is equal to 20%. Pardon these questions still over there. Those are the ones that we've been working with just as a cue for me. So 20% change. They could also give you the percent change and possibly the initial or the final information, and you would have to substitute into our formula and then do algebra to solve for things. we kind of did a little bit of a segue. I kind of introduced something else. We're going to go back to a similar property that we learned before. Find a number decreased by 20% to be 160. I should have done this question first, before percent change, whichever. Find the number decreased by 20% to be 160. So what we learned on the last page is take the number and multiply it by the multiplier and give you some other number that you want. So I don't know what the first number is. I'm going to call it x. Now if I want to decrease it by 20%, 1 minus 0.2 equals 0.8. So I'm going to times it by 0.8. And that number is 160. So there's some quick algebra that we're going to do later in equal fractions, but I'm just going to show you a very simple example. 2a equals 6. Well, 2 times a is 6. 2 times what equals 6? We know the answer. 2 times 3 is 6. We know the answer is 3. We have to do an algebraic method by doing the same thing to both sides. We're going to divide both sides by 2. 2 divided by 2 is 1. It's gone. And we know a equals 3. Put it back in. 2 times 3 is 6. Check mark. I'm going to cloud this stuff. It's not a formula for a box. It's not exactly what we're doing right now, but it's a thing that we're going to be doing later and something we absolutely need to know how to do. So if I have x times a variable, I can simply divide both sides by that variable, cross it off, and x equals 160 divided by 0.8 is 200. Keep in mind, I could have turned that into a fraction and done fraction rules. Circle my answer. I could check my answer by doing a whole bunch of stuff. Okay, the last question on this section. Jack ate 40% more than Jill. How many did Jack eat? Well, it's a word problem. I'm going to define my variables. Let J equal the number that Jill ate. Now keep in mind, Jack and Jill, bad names because J and J, and it doesn't work very well, but that's why we declare our variables. So first of all, 40% more than Jill. What's our multiplier? Well, that's just simply 1 plus 0.4 equals 1.4. Our multiplier is 1.4. So let's start off with over equals over. So what I know is that however many Jill ate, our defined variable J, well, Jack ate 4 more than that. So how many did Jack eat? Well, the number that Jill ate, J, plus 4. And we know that that is, our multiplier is 1.4, or we can use decimal over 100, percentage over 100, so 140%. Off to the right, 1.4 is 140%. Going into our formula, is over of equals percentage over 100. Now, Jill ate just 100% of what she ate. So that's a very difficult question. You're probably not going to see it, but check out the notes, cross multiply or whichever. Eventually we solve for J. J equals 10. Therefore, Jill ate 10, and if Jack ate 4 more, Jack equals 14. So, in review, we're going to use is over of equals percentage over 100, finding parts of things. Then we're either going to use is over of equals percentage over 100 and then add or possibly subtract a number, or just simply multiply by the decimal you want to be. Multiply by the decimal you want to be. So when we do harder questions, it doesn't stop us. Little bit of a segue into percent change, and then some much more difficult algebraic processes down below that will probably come easier in later years and are usually only for more advanced students, but sometimes they throw them in there.